Hi guys, welcome back to my YouTube channel, and today we'll be doing partial fractions from A-level maths. I took these questions from the Pure Year 2 book, exercise 1D. So let's get through them. So first one, what you want to do is make sure that the brackets, that the denominator is always in the form of brackets. So in this case it already is. So we can just write this single fraction. We can say that this can be represented as a over one of the factors plus b over the other factor, and then we want to find what a and b are, so we can represent it as two separate factors. So what we can do is we can compare coefficients. So if we would want to make this back into one fraction, we would cross multiply. So 6x minus 2 would be equal to a lots of x plus 3 plus b lots of x minus 2 all over the x minus 2 times x plus 3. I'm just going to leave that out because I'm going to compare the numerators. So we can say, if we compare coefficients, the only way to get 6x from this side is over here. If we expand this, we would get ax plus 3a plus bx minus 2b. So the only way to get 6x would be your ax plus bx, and then the only way to get your negative 2 is the 3a minus 2b. So we can just solve this. If I say 6 is equal to a plus b and minus 2 equals 3a minus 2b, we can just solve these simultaneously. So if we multiply the top equation by 3, we get 18 equals 3a plus 3b. And if we write the bottom equation out again, then all we need to do is take these away. So we get 20 is equal to 5b, so b is equal to 4. And if b is 4, then a must be 2, because 4 plus 2 is 6. So then we can write this, if a is 2 and b is 4, we can go back and write this as 2 over x minus 2 plus 4 over x plus 3. And we can also check that. So if we have, if we cross multiply 2x plus 3 plus 4 lots of x minus 2, so that would equal to 2x plus 6 plus 4x minus 8. This would simplify to 6x minus 2, which is the same as our numerator. So that's how we know that we've done it right. Okay, 1b, we can do b. 2x plus 11 and x plus 1, x plus 4. Okay, so we do the same thing. It's in two brackets already, the denominator. So we can split it into a over x plus 1 plus b over x plus 4. Now, we can do the same thing. So we can compare 2x plus 11, the numerator on the left side. On the right hand side, your numerator would be a lots of x plus 4 plus b lots of x plus 1. And then we compare coefficients. So we would have 2x and 11 on the left side, and on the right side, if I expand this, I'll get ax plus 4a plus bx plus b. So we know 2x is equal to ax plus bx, and the 11, the constants, would be 4a plus b. So then we can solve these simultaneously. If I write this out again without the x's, 2 equals a plus b and 11 equals 4a plus b. If I call this 1 and 2, we can do 2 minus 1. So we would just get 3a is equal to 9. So a is 3. And if a is 3, then b must be minus 1 to make a plus b equal to 2. So we can also check this if we go back. So a is 3, b is minus 1. So if we write it like this, and then if we multiply out, see if we get the same numerator. So we get 3x plus 12 minus x minus 1 minus x, which will give us 2x plus 11, which is the same as our numerator here. Okay, let's go on to the next question. Minus 7x minus 12 and what was it, 2x x minus 4. Okay, so these are our two factors. This is a bit different because one of them only has a x term in it, but it's the same process. So we can say this is the same as a over 2x plus b over x minus 4. And then we can do minus 7x minus 12, compare the numerators, cross multiply, a lots of x minus 4 plus b lots of 2x. Then we compare coefficients. So minus 7x would be equal to, if we expand this, ax minus 4a plus 2bx. So minus 7x, the only thing it could equal to is minus ax plus 2bx. And the other part, the minus 12, would be equal to minus 4a because that's our only constant. So we can just solve this straight away, because if minus 12 is minus 4a, then that would mean that a is just equal to 3. And if a is 3, we can write this down again. Minus 7 is equal to a plus 2b. And if a is 3, move the 3 to the other side. So b equals minus 5. So we have a is 3 and b is minus 5. So if we can check this, we expand and see if we get minus 7x minus 12. So we get 3x minus 12. Then we get minus 10x. If we cross multiply here and here. So we get minus 7x minus 12, which is the same as our numerator, which means we've done it right. Okay, 1d, 2x minus 13, it's the numerator, and the denominator is 2x plus 1, x minus 3. 2x plus 1 and x minus 3. Okay, so same process. Write this as two fractions with each denominator being one factor. Next, we cross multiply and compare the coefficients of the numerator. So comparing coefficients of the x values and the constants. So we have 2x minus 13. So we have ax, let me just expand this first. Ax minus 3a plus 2bx plus b. So ax plus 2bx would be equal to the x term, and the minus 3a plus b would be equal to the constant term. So we would have to do, if I write this equation out again without the x terms to make it easier to see our simultaneous equations, if we multiply the second equation by 2 to get the b terms the same, we get minus 26 is minus 6a plus 2b. And if I write out our top equation again, now all we have to do, we can take these two equations away. So we would get 28 is equal to 7a. So a is 4, and if a is 4, we can sub that into the first equation. 2b would equal to minus 2, so b would equal to minus 1. So if we sub these back in, a is 4 and b is minus 1 into our original. 4 over 2x plus 1 plus, negative 1 over x minus 3. Then if we cross multiply, see if our numerator is the same. 4x minus 12 minus 2x minus 2x minus 1, we would get 2x minus 13, which is the same. So yeah, it's quite easy to check your answers because you can just sub back in your values for A and B and see if you'd get the same answer. So it's quite easy to see if you went wrong or not. It's the same process for all of these types of questions. You write it as two fractions with the denominator being each of the factors. You cross multiply to find what the numerator would be on the right side. You compare the coefficients and then you solve simultaneously, or sometimes you don't even have to, because if you have a constant like here, you get an equation for A, or you'd get B as one thing, so you don't even have to solve simultaneously. So yeah, that was it for this video. I'd really appreciate it if you like and subscribe, and I will see you in the next video. Bye.